Welcome to the third episode of the Sedrica Series. Let's talk about the Motion Planning Subsystem. How will you find a market in an unknown city? Google Maps. That's right, you'll need a map and a path to reach there. That's where motion planning comes in. One of the most essential tasks for any self-driving car. Motion planning basically means providing complete information of the path to the robot, including the stops and the speed to be followed. We accomplish this using the data from computer vision and localization subsystems to make an occupancy grid out of it. Now this grid is what we love to play with. We select and let loose our path planning algorithms to calculate the most optimal and feasible path. One of our successfully implemented algorithms, Hybrid A*, has achieved a speed of around 15 frames per second. It is the most reliable algorithm we have to date. We are using the curvature method to find out velocity at each point in the path, and with this we pass the ball to controls. As the motion planning subsystem of Sedrica, we have some future goals lined up. The first is dynamical motion planning. The current model assumes the environment at rest and plans the path on a static map. Achieving an optimal dynamic planner is our broader goal. The second goal is parking for autonomous vehicles. For this, we plan on using an algorithm consisting of two steps: space exploration and heuristic search algorithm. And just like the essence of the subsystem, these problems are being tackled by doing research, then ideation, and finally implementing and testing it out for real, as many times as it takes. That was all about the Motions Planning Subsystem. Stay tuned for the next episode of the Sedrica series.